Yeah, so here's what we're gonna look at right in this topic. So first we're gonna look at the regions. So as I said, this is going to be type 1 region, right? As to why, because say that we consider this, we look at dy dx. If we have dy dx, that is type 1 region. Or on the interval, you have x. You say right now, here, the equation of x, therefore that is type 1 region. And the question is, how do I draw this? Sometimes you can be given this, sometimes you can be given this. So let's see how do we draw either of that. So you're gonna be given two intervals. You see, right? One of them must have some equation in it. So how we draw this is this: the one which has, let me focus on this. The one which has values only should be on the outside always. You see, right? X is between a and b, and the one which has equations or an equation and some number should always be here inside. Now let's check this. We realize that the one which is outside is with respect to x. It means that outside we're going to put x. And the one which is inside is with respect to y. So we'll put y inside the y. You see right now. So again, how do we move from here to a region? So we're just going to do the same thing. A, B, we check what this is. It's between x. It's outside, you say right now. So we're going to focus on the outside, also on the other side. So we say that this we're going to have x between a and b. And the one inside is between y. So we're going to have those endpoints between y. And then that will be our region. Question is, how do I change to a next region? So now we'll consider that question after we've looked at the second region, the type 2 region. So when we look at the type 2 region, here we're also given two coordinates. But if you see y here, that will be your type 2 region. But if you see dx dy, that will be your type 2 region. So you can just focus on y here. Then type 1 region, you focus on x being here. So now when we check this, I've shown you how to draw this, right? CD, this is y, so it will be outside the y1, right? The y. Then is this between x, so we'll have the x inside. Now we do the same thing when we're drawing from here to there, right? So now let's look at some example. Let's look at some example, changing order of integration. Then we have this. We're given this question. We see that the outside integral is between 0 and 1, and that is with respect to x. So I'm going to put this between x and I'll put 0 and 1, and they should be less or equal to or greater or equal to. You see right now. And then inside I have root of x until 1, then that is between y. We see this. Then I'll write that. Now, for us to change to the second region, is what we should do. We focus on this, the one which has an equation. Now I'm going to write this. I want to show you this. First you write this. This is just as it should be, right? You can change these things without even drawing. You see this one is saying x here, so I'm going to put y. This one is saying y there. I'm going to put x. So what you should do first, you change this to x less or equal to y squared. This will tell you here, you see the one which doesn't have an equation, you must inherit one side. It's either inherit this one or this one, and the other one you must get it by plugging. Is right. So this one will tell us which one should we inherit from that side. So now when I check this, I'm having x is less or equal to y squared, so we're going to plug that. It means that I must inherit this side. You see right, I'm going to inherit x is greater or equal to 0. Now for us to find this side we're just going to plug only. We're going to plug our values. So remember, y is equals to root of x. So when I plug 0 here, I'm going to get 0. When I plug 1, I'm going to get 1. And that is our type 2 region. Now let's look at our type 2 region. That will be the type 2 region, which is the same thing. You see right now, y is between 0 and 1, which is the same thing there. And x is between 0 and y squared, which is the same thing. Now let's focus on the second one, which is this one, right? This one, it's on the exercise, but the exercise has been solved. So let's look at it. 0 and 1, this is with respect to x. That's why here we put 0 and 1 between x. Then x squared and 1 is with respect to y. That's why we put them between y. Now I want to draw another region. Remember I said that the moment you see x here, this is a type 1 region on the equation. So we're going to draw the second region, the type 2 region. We draw type 2 region. On type 2 region, since this is x, I'm going to change it to y. This is y, I'll change it to x. So I said that between these two, I must inherit one side because this thing doesn't have an equation, right? So I must inherit either this side or this side. And then this equation will tell us which side I will inherit it. So when we check here, if I make x subject to the formula, I'm going to get that x is less or equal to root of y. So it means that x is less or equal to root of y. So I'll inherit this side because it's empty. You see right now? Then for us to find these y values, we must go where y is the subject of the formula. Let's say y is equal to, we're just going to take it as y is equal to x squared. That again, when we draw a graph, we'll draw a graph of y is equal to x squared. Then when I substitute 0 there on x, I'm going to get 0. When I substitute 1, I'll get 1. Then this will be the interval. Now let's look at let's confirm this interval. This is between 0 and y is between 0 and 1. And x is between 0 and root of y. We say right. So I'm going to try to make this as short as possible. So let me see if there's another question. Okay, this one's for polar coordinates. Then let's look at that other example. So I give you a clue here. So okay, I know that once I give you a clue, you'll be able to integrate. So with this one, A, right? I'll draw the first region we see there, which is type 2 region because I see y here, right? So this will be x, y. Already, I see here that this is with respect to y. You see, right? So those values 0 and 8 are between y. No, y is between those two values, right? And then we have x squared. It's not x squared. We have root of y, cubic root of y. Obviously, this one should be x and 1. And that is it's up until 2. Right? So now I want to write it the second region. Now, for us to write this second region, we must change this to x, change this to y. And then first we must check, are we going to inherit this or this? We're going to check that. So we see here that if I make this subject the formula, I'm going to make this subject the formula, make y subject the formula, I'm going to have this less or equal to x cubed. So it means that this will be x cubed. Right? Y is less or equal to x cubed. So it means that here I'll inherit 0. You see right now? And then for us to find this x, we'll come back here. We'll just take x is equal to cubic root of y. Then we start plugging. When I plug 0 there, when I plug 0 on y, I'm going to get 0 here. When I plug 8, remember when I plug 8, I'm going to get this 8 to the 1 over 3. And 8 is the same thing as 2 to the 3, 1 over 3. So this will cancel out, so I'll get 2. You see, right? Now this will be the new region for that equation. This from 0 to 2, from 0 to x cubed, then this was e to the x4. Then we see that what's inside is this, right? It's the y, and what's outside, it's the x. So you can integrate simply this, because we see that there's no y here, so it means that e to the that is a constant. So I'm going to have 0 to the 2, then I'll have y e to the x4, and then this will be 0x cubed dx. The reason why I'm changing this, you won't be told that, right? Let's focus on this. Let's check this. Guys, every time you're dealing with E, you first focus on U substitution, then secondly you focus on by parts. First, let's focus on U substitution. U substitution says that we're gonna be given an integral, or yeah, let's say integral, which has two expressions inside. So here, this has two expressions, which the expressions are 1 times e to the x4, all right? And then we focus on the one which is difficult to derive, the one which looks difficult to you, right? And here it's what? It's e. When it's e, we're going to let its exponent to be u. When I let this to be u, when I derive this, I'm going to get 4x3 dx. Now, let's focus on this. Before we make anything subject to the formula, let's focus on this. Is there x to the 3 here that can be cancelled by this? No. So it means that U substitution won't work. Because after making this subject to the formula, after deriving, whatever that remains of x should be cancelled somewhere here. So it means that U substitution won't work. We'll look at by parts. By parts is that since we have these two equations, we're going to say that the integral of u dv is equal to uv minus the integral of v du. So by parts is that I'm going to use Liat. I don't have to think, this time I don't have to think about difficult or simple, right? I'm going to use Liat. And the one that comes first, it must be u. And we see that one is algebra. One is algebra. And e is what? Is an exponential function. So now we see that if I let u be equals to 1, when I derive it, I'm going to get 0. So wherever I have to plug u, I'm going to get 0. When I have to plug du, I'll have a problem because this will automatically become 0. You see right now? So this is not allowed. So this is not allowed because I'm going to get du is equal to 0 dx, and 0 dx gives us 0. So it means that this is going to be before I even find what is my u and v, right, I'm just going to say this will be this v0. Integral cannot go, the integral sign cannot go alone. It needs some something here. You see right now? So it needs to integrate with respect to something. Let's say if I have x, I'm going to integrate with respect to x. I have du, I'm going to integrate with respect to du. You see, with respect to u. You see right now? So it needs that something. If you don't write here, this remaining part, your integral sign, your integration is wrong automatically. So that's how we see, are we supposed to change the coordinates? So when I say that this doesn't work, I can change the coordinates. Let's look at the second one, why we had to change the coordinates. So the second one here, we're given that the root of y, sine of y. Check this. There's no x here. So it would be simple for us to integrate using x first. Because this, yes, it can be integrated. We can integrate it using by parts. Because we can let this be u because it comes first in Liat. It's an algebra. It's a trick. We can let it be dv. But this makes our life difficult because we must integrate for the second time. Integrating for the second time with a complex function will be difficult. There's no x here. Why can't we change the coordinates? So that we can first integrate with respect to x. So that when we integrate with respect to x, we're just going to get what? We're just going to get x here. You see, it's simple. You get 3 marks there. So let's check. You see, we had to change it to that so that we can first integrate. We just get x there. We plug this. When we plug the root of the root cancels, we're left with y sine y. Now we use our by parts. Things become simple as that. We say, right, now that is simple. So here, if we check, we did let this be u and let this be dv. When this become dv, we had to now integrate it. How do we integrate sine y? So let me show you how. Now, I'm just giving this right so that you don't confuse. Some they confuse, they don't know that the integral of sine y is negative cos y. And some they don't know that the integral of cos y is what? You see right now. So when we come here to this one, remember when we integrate cos y, we're going to get a positive sine y. So some would mistakenly write negative 1, right? So in this case, we're going to do what? We're going to write this. We're going to write sine y negative sine y. We're going to write cos y negative cos y. So I ask myself, when I derive positive cos, I get negative sine. So it means that this is going this direction. Right? It must go in that direction. When I derive negative sine y, I get negative cos y. When I derive negative cos y, I get positive cos y. So this is for the deriving. I can just write dy. This is for deriving, right? And then for integrating, I'm going to write the same functions. Actually, let me not even change this. The red one is for deriving. Then for integrating, I'm just going to go back. You see right now, I'm just going to go back. It means that when we come back here, we're integrating positive sin y. So when I integrate positive sin y, I'll get negative cos y, which is that, the negative. You see right now. So you must keep this in mind. So the integral will be that, will be the blue one. So this is how you can do. So let me just stop the recording here. If you have any question, you can now, please make sure you go through the slides, try to understand, like every information is here in detail. Try to check if this is happening. Try to check the pattern between these exercises, like how are they done, like these examples. Try to check the pattern. Why are they doing this? You must ask yourself. Don't just write. So that you must learn in detail, so that if you're gonna be doing maths next year, remember, mostly in final there are no tutorials. There are less tutors. You may find that there's one tutor, and you can't always depend on tutors, right? So the aim is for you to be independent. So you must be able to look at a problem. You are able, or maybe you look at a theorem or an example, you are able to generate something out of it, or a simpler explanation. So yeah, then I'll stop here, guys.